So I'd like to start the hearing by calling on the presentation from McMaster University as an outlining Commission Member Document CMD 14H4.1 and 14H4.1A, and I understand that Dr. El-Bestawi will make the presentation. Please proceed.
Thank you, Mr. Chairman. Good morning, members of the Commission. My name is Mo El-Bestawi, and I'm the Vice President of Research and International Affairs at McMaster University. I'm pleased to be here this morning to address the Commission in support of the renewal of the McMaster Nuclear Reactor's operating license. The University is respectfully requesting the Commission renew our non-power operating license for a period of 10 years. I am joined today by some of the key members of our team responsible for the safe and efficient operation of the reactor. To my left is Chris Heisel, Director of Nuclear Operations. To my right is Dave Tucker, the university's senior health physicist. Behind us is Mike Butler, the Manager of Reactor Operations, Robert Pasuta, Reactor Supervisor, and Brandon Johnston, Manager of Quality Management and Training. The McMaster Nuclear Reactor is an important asset to the university. It is at the heart of what makes us Canada's nuclear university. It is an invaluable research and teaching tool that is central to programs in nuclear engineering and applied radiation sciences. The reactor continues to have an important role in the production of medical isotopes, and it is a unique and essential tool for local high-tech industry. We are very proud of the accomplishments that we have made at the reactor through over the current license period. Most importantly, we have maintained our very strong performance in safety and security. That is always our top priority. We have made significant improvements in key areas that were identified as priorities at relicensing, including fire safety, quality management, and training. We have accomplished this during a busy period of increased facility utilization, expansion of research facilities at the reactor, and significant renewal of our infrastructure at the facility. The expansion and investment at the facility continues. We have several new research facilities planned for over the next license period, which will continue to position McMaster at the forefront of university research in radiation sciences. Infrastructure improvements will also continue in order to ensure safe, secure, and compliant operation of the reactor for years to come. Thank you for this opportunity to make our opening remarks, and with your permission, I will now ask Mr. Heisel to make our presentation.
Thank you, Dr. El-Bestawi. For the record, my name is Chris Heisel. I'm the Director of Nuclear Operations at McMaster University. It is indeed my pleasure to address the Commission members this morning, members of the CNSC staff, and members of the public in support of the renewal of the university's non-power reactor operating license. The McMaster Nuclear Reactor is an important Canadian asset supporting research, education, and medical isotope production. MNR is operated in a manner that proactively and competently safeguards workers, the public, and the environment. A 10-year license is respectfully requested. McMaster University is a medium-sized yet research-intensive university located in Hamilton, Ontario. The university includes 21,000 full-time undergraduate students, 3,500 graduate students, and 7,000 staff members. The annual research budget for the university is approximately $400 million, and the total university operating budget for fiscal year 2013-14 was $982 million. The circle denotes the location of the university, and the white dot is the approximate location of the reactor. McMaster University is Canada's nuclear university with the most comprehensive suite of nuclear facilities at any Canadian university. There are a sizable number of approved and funded projects being carried out at McMaster with the radiological safety infrastructure in place to support the wide range of activities occurring in radiation science and medical isotope research, development, and production. MNR is the only research reactor in Canada with a full containment structure. This structure supports the strong safety and security case for the facility. The reactor building is adjacent to the nuclear research building, which contains a large suite of active laboratories and houses staff and researchers using the facility. MNR is a materials test reactor licensed to 5 megawatts, which currently operates between 2.5 and 3 megawatts, 16 hours a day, 5 days a week. MNR contains an array of research facilities, making it a flexible research and educational tool. The reactor is an important supplier of medical and industrial isotopes. The reactor is operated in an efficient manner to provide a reliable source of supply to our customers. Cooling of the core is passive. The fuel is cooled by gravity flow. Heat of fission is removed from the primary system by 2 heat exchangers operating in series. The 400,000 liters of water in the pool provides cooling, shielding, and a massive heat sink for the shutdown core and the associated decay heat. No electricity or other services are required to achieve or maintain a safe shutdown state for the reactor. MNR is aligned with the main missions of McMaster University. It provides students in a wide range of academic disciplines with a hands-on educational experience. The reactor enables researchers at the university throughout Canada and around the world to further their investigations through access to our unique suite of research facilities. A variety of industries use the facility for R&D, non-destructive testing, and analysis. McMaster University prides itself in its community outreach commitment. Each year, thousands of university and high school students tour the reactor and learn about nuclear and radiation sciences. MNR has an array of commercial products and services. Revenues from these activities are used to support and enable research and education. The local economy also benefits from MNR. 35 direct and over 250 indirect, highly qualified individuals are employed in the Hamilton area due to the reactor's continued operation. The photo on the left is a slide of a neutron radiograph of a turbine blade taken to detect manufacturing defects in this part. Over 90% of all blades used in the manufacture of aircraft engines in North America are qualified using MNR facilities. The reactor is a major global supplier of the medical isotope iodine-125 and ships product around the world every week. The amount of this isotope produced at the facility each day is equivalent to that required to treat over 100 dads, uncles, sons, or brothers. MNR is also an important producer of other medical isotopes, which are supplied to Ontario researchers in the development of next-generation diagnostic and therapeutic agents. The reactor has been very busy over the current license period developing and implementing a systematic approach to training for the reactor operator and reactor supervisor positions. Over the period, 3 certified reactor operators have retired from MNR and 4 assistant reactor operators have been hired. Certifications recertification exams were held for 3 reactor operators and 1 reactor supervisor, and all 4 candidates were successful in achieving recertification. 6 candidates were successful in achieving the initial certification for the reactor operator position. The SAT training program was completely documented, and all procedures describing the program were issued. The program meets all of the license requirements. Significant efforts have been made on the management systems at M&R over the current license period. The university has established a leadership role within the organization to oversee the management systems program. Since 2011, accelerated progress and improvement have been achieved in all facets of the program. The 2013 CNSC inspection focused on the management systems program, resulting in closing of all open actions in the safety and control area. Consolidated database was implemented for nonconformance, operating experience, corrective action, and document control activities. This database is currently being expanded to include the areas of training and audit. Also, the work planning and control processes were revised to improve how work at the facility is authorized. Operating performance over the license period has been strong. There were no major unplanned outages. Reactor availability was on target, and careful outage planning resulted in meeting or exceeding user demands during the implementation of the major infrastructure improvements executed during the current license period. The M&R Safety Analysis Report was revised in 2012 to allow for improvements to backup power supply for the facility. The single 35 kilowatt motor generator supply was replaced with access to 4 1 megawatt university diesel generator sets, increasing reliability and redundancy of supply. In response to the Fukushima accident, M&R engaged the services of a safety consultant to perform a defense in-depth review of the facility. The D&D review was a systematic and comprehensive review of M&R against requirements of applicable defense in-depth standards. The review concluded that M&R has strong provisions for protecting workers, the public, and the environment against internal and external hazards. Accident management and emergency response provisions at M&R are sound and can deal with beyond design basis accidents, including those with prolonged unavailability of external services. No significant defense and depth gaps were identified. Despite the fact that no gaps were identified, to further strengthen the safety case of the facility, a number of opportunities for improvement were identified during the review. These opportunities were technically assessed and formulated into a set of recommendations. The status of the recommendations are as follows. A recommendation to provide a tie-in point for a mobile generator was completed during the extensive electrical upgrades conducted in 2011. A core spray system was recommended for an incredible event where the pool inventory is lost and the core cannot be isolated. A spray system has been designed and installed to address this recommendation. A building flood system was proposed to provide a separate and independent method to cool and shield the core. A new system has been installed. An additional recommendation included a provision for remote monitoring of level and reactor parameters. A high-resolution camera with pan, tilt, and zoom capabilities has been installed in the M&R control room to address this recommendation. It was also suggested that an inventory of university equipment available to deploy in an emergency be compiled. A detailed and comprehensive list has been created and is included in the supporting material for M&R emergency preparedness. Additionally, it was recommended that the university extend its investigation into fuel and air cooling provisions. A review of literature conducted during the defense in-depth review indicates that air cooling is adequate to prevent fuel damage at MNR. The approximate decay heat would give off about 0.2 watts per centimeter squared. A research project has been initiated to verify this assumption that air cooling is adequate to prevent damage to fuel at MNR. During the current license period, MNR has completed major refurbishments to a large number of MNR facilities. This was made possible largely due to a government knowledge infrastructure program award to the university focused on medical isotope research. This funding was helpful in accelerating many of the planned aging management refurbishment projects at the facility. During the current license period, MNR created an aging management plan following international guidelines. Major refurbishments have been completed as detailed in the CMD. Non-destructive surveillance programs were initiated on the primary water system piping and the main heat exchangers. No significant degradation has been indicated. Routine surveillance testing, like that shown in the containment air leak test results graph, continue to monitor and verify that systems are operating within technical specifications for the facility. I will now call on Dave Tucker, the university's senior health physicist, to lead us through the next set of slides.
Thank you, Mr. Heisel. Dave Tucker from McMaster University. Safety of our employees, facility users, and members of the public is a paramount concern in every aspect of our operations. In the next few overheads, I'll review some of the highlights of safety performance at MNR during the recent license period. There were no lost time accidents associated with the licensed activities during this period. All doses were far below regulatory limits. There were 2 incidents at the facility which have previously been reported to the Commission, during which action levels on dose were exceeded. Investigations of these events were completed and all corrective actions successfully implemented. The figure at the right shows the collective dose by year for all of the groups with individuals exceeding 1 millisievert per annum, the significantly exposed groups. In every year, this includes reactor operations staff, iodine production staff, and neutron radiographers. In 1 year, 2011, 2 other groups had individuals with doses over 1 millisievert as a result of major facility maintenance and active waste removal campaigns. Health physics staff and contractors who completed extensive work in the pump room. Through part of the license period, an upward trend in collective dose was observed as facility utilization was increasing. The peak value was observed in 2011, and collective doses have been steadily decreasing ever since, although facility utilization remains high. As of 2013, the facility collective dose was down approximately 40% compared to the start of the last license period. I will discuss some of the contributors to this decrease in the upcoming overheads. One aspect of overall program improvement that occurred during the license period was the introduction of a formal annual radiation safety program assessment. All available data and performance indicators are gathered, and self-assessments against goals are performed by senior M&R and health physics staff. New goals are set for the coming year. The detailed assessment is then presented to our internal oversight committees, the Health Physics Advisory Committee and the Nuclear Facilities Control Committee, at a joint meeting. Results are updated and reviewed quarterly. This has been a helpful process in maintaining focus and priority on identified aspects of the radiation safety program. In our CMD, doses are presented in the context of dose limits, and I know this data will also be presented in CNSC staff's presentation. The next few overheads show you the performance tracked in a slightly different way. Collective dose per normalized production. Given that doses are far below limits, which they are, this is the appropriate metric upon which to focus the facility ALARA program. To illustrate the application of this approach to monitoring, consider the reactor operations staff. Operating hours and operating power can be adjusted according to demand. With more operation, we would expect higher personnel doses. so simply tracking the collective dose is a poor indication of optimization. What we want is the most hours of operation at the highest needed power for the lowest reasonably achievable doses. This figure shows the normalized operations staff doses, the collective dose per energy output at the facility. As indicated, this value is at its lowest in recent years, and in fact, it's the second lowest value in the operating history of the reactor. This is the result of a number of areas of continuous improvement in facility conditions and procedures. The most significant contributor is believed to be suppression of the short-lived activation products in the reactor primary water, resulting in decreased ambient radiation fields. This figure shows the collective dose for iodine production personnel normalized to their output as relative production of the medical isotope iodine-125. The figure shows the history since production of iodine-125 started on a large-scale basis. Results for 2013 are at levels near to the lowest we have been able to achieve. In part, this improvement is also the result of lower ambient radiation fields around the reactor pool, as previously mentioned. Various other incremental improvements in procedures and equipment have also occurred. The final slide shows the normalized collective dose for the neutron radiographers, where output is the relative number of films produced during their important work inspecting turbine blades for aircraft engines. Exceptional improvements were achieved through 2012 and 2013. This was previously the highest exposed group of workers at the university. Now many of the radiographers do not receive measurable doses. This increase was the result of commissioning a new beam port with extensive shielding improvements, implementation of additional procedural controls, suppression of short-lived activation in imaging components, and increased staff awareness of sources of exposure. Environmental protection is a high priority at M&R. We are extremely conscious of our location and strive to maintain all emissions at de minimis levels. There have been no discharges of active liquid waste to the municipal sewer system since 1989. All active liquid waste is captured and conditioned for use in the reactor primary water system or evaporated. Airborne effluents are maintained at a level that would result in doses of less than a microsievert for a person with continuous occupancy at the point of maximum ground level concentration. No action levels or regulatory levels were exceeded, and DRL calculations were updated to the latest CSA standard. Continual improvement in the M&R Emergency Preparedness Program continued through this license period. Significant investments in emergency preparedness infrastructure have been made at the university, which have strengthened the facilities program. These include, for example, installation of a mass public address and alerting system, implementation of an automated notification system for facility personnel with emergency response duties, and a major upgrade to the two-way radio system on campus. Close ties with the city's emergency responders and hospitals have been strengthened through extensive cooperative efforts on areas such as training, drills and exercises, procedure development, and equipment support. An evaluated radiological fire exercise was conducted at the facility in late 2010 in conjunction with the Hamilton Fire Department, with participation from a broad range of city and campus emergency responders. Planning is currently underway for a contaminated casualty exercise planned for late 2014. M&R personnel strive to make a positive contribution to the community's emergency preparedness capabilities, supporting activities such as preparedness for the upcoming Pan Am Games. Thank you. Mr. Heise will now complete our presentation.
Chris Heisel for the record. As shown in the CMD, extensive physical improvements have been made in the area of fire safety at M&R. Additionally, a full fire hazards assessment of the facility was completed. This independent assessment concluded that all nuclear safety objectives are met. No credible fire can challenge the capability to establish and maintain the safe shutdown state of the MNR facility. This assessment concluded that all environmental protection objectives are met. No credible fire can cause a significant release of hazardous substances from the reactor building into the outside environment. Further, the assessment concluded that all life safety objectives are met. Integral provisions for early evacuation of the reactor building are provided. And finally, all radiological safety objectives are met. Public safety is achieved by meeting the environmental protection objectives. Worker safety is met by the timely evacuation of the reactor building, which is facilitated by the unique MNR capability to quickly establish a safe and unattended shutdown state of the facility. The assessment provided a set of recommendations to the university to enhance fire safety. All of these recommendations have been implemented. A total overhaul of the security monitoring room was completed during the license period, resulting in enhanced monitoring capabilities, improved ergonomics, and significant advances in technology. Prior to starting construction, a second monitoring room was constructed and commissioned. This second monitoring room remains available as a backup to the primary location. Other activities in the safety and control area included deployment of a new radio system, the purchase of a new emergency contact system, additional security infrastructure, and 2 updated site security reports. Additionally, a number of key university staff members were cleared to top secret to allow enhanced communications between the CNSC and other security groups directly with reactor staff. Over the license period, several IAEA and CNSC inspections took place at the reactor, including physical inventory takings and design verification inspections. No issues were raised as a result of these inspections, and all safeguard obligations were satisfied. In 2009 and 2012, MNR received fresh fuel shipments consisting of LEU standard and control fuel assemblies from our fuel manufacturer in France. In 2008, a spent fuel shipment resulted in the removal of all HEU from MNR. MNR ships and receives radioactive material in accordance with the Packaging and Transport of Nuclear Substances regulations. Staff are trained and certified to satisfy these regulations, as well as those of the Transportation of Dangerous Goods regulations. No incidents occurred, and all expectations were met or exceeded over the period. Over the current license period, MNR made approximately 2,000 radioactive shipments, consisting of mainly medical isotopes and research samples. The most significant shipment made during the license period was the 2008 spent fuel shipment. McMaster University has a wide-ranging public outreach program led by our Public Relations Department. The university program is supplemented by extensive outreach activities at the reactor. MNR has a comprehensive website which provides important information to the public regarding MNR, including OPEX events originating at the facility. The reactor hosts numerous list servers providing professional and public dialogues on radiation and nuclear sciences and the sharing of OPEX. Each year, over 2,000 students and visitors get to view the blue glow of MNR. This first-hand experience with an operating nuclear core helps demystify nuclear technology for them. A report containing annual doses and releases are published on the university website. MNR is currently preparing a public disclosure protocol. The university's extensive media interactions provides expert opinions to the public regarding MNR and current events. Examples include the Fukushima events and the medical isotope crisis. Responsible operation includes responsible provisioning for decommissioning. The preliminary decommissioning plan and the associated cost estimate for M&R were updated in 2011. McMaster University has established a nuclear reactor restricted reserve to fund the eventual decommissioning of the facility. The fund has shown steady growth over the license period despite the global economic downturn. The university expects the restricted reserve to be fully funded during the upcoming license period. This table summarizes some of the significant investments made by the federal government and the provincial government at McMaster University in the areas of radiation sciences and medical isotope research and production. These considerable investments demonstrate the strong current and future commitment by McMaster University, the Government of Canada, and the Province of Ontario to nuclear technology R&D at the university. Clearly, M&R remains at the core of discovery. In summary, the McMaster nuclear reactor is an important Canadian asset, supporting research, education, and medical isotope production. M&R is operated in a manner that proactively and competently safeguards workers, the public, and the environment. A 10-year license is respectfully requested. Thank you for your attention.
Thank you.